Udi Dahan on Microservices.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Hello again, I'm your host, Jeffrey Palermo. Remember, you can go to www.azuredevops.show for past episodes and show notes. And, well, we've got a lot of good shows in the bank, so make sure to go to that website. You can also find us on Twitter at Azure DevOps Show. And our guest today is Udi Dahan. He is the founder of NServiceBus, the CEO of Particular Software, and Microsoft Regional Director. And I'm really excited to have you, Udi. How are you, man?
Hi, Jeffrey. Good to be here. I'm doing well, thanks. How are you doing?
I'm good. We saw each other a few weeks ago at the MVP Summit, and glad you made it home safe.
Yeah. It was a great event. Great seeing you again, and so many faces that I haven't seen for quite some time. Yeah.
Awesome. So for those who might not be as familiar with you, you've been doing software for a long time, and you founded NServiceBus a long time ago. Why don't you catch the listeners up on what your journey has been?
Wow. Okay. Well, let me see if I can give sort of the 30-second compressed thing. Started programming when I was 8 years old. With a computer that my dad brought home from the university. Started programming professionally, getting paid at around 19-ish. At the time I moved to Israel, joined the army, also worked there as a programmer, learned what mission-critical software actually meant, how to build it. A lot of that was based on async message passing patterns. From there, got involved with .NET and continued building those types of really large-scale distributed systems. A number of years later, went and became an independent consultant, at the same time that blogging took off, speaking at conferences, all of that. And over the years as an independent consultant, I saw that many of my clients were struggling with building their types of distributed solutions. At the time, I think WCF was the craze. So this was kind of pre-REST craze. And so I started with MSMQ, and there was MSMQ support in WCF, but it wasn't really great and it wasn't really native. That's when I started NServiceBus as an open source project. More and more people started using it as they found out that, hey, actually, using queue-based asynchronous invocations is a better way of building distributed systems. A number of years, making that open source project successful, I began to realize that, it's really hard to do that at scale by yourself.
Yeah.
And then I kind of took a gamble and said, I think I should commercialize this because it's gotten beyond what I can do. And while it's kind of great that I can do sort of the training consulting way of building a business around this software, companies were saying, well, that's great, but we want 24/7 support. I would love to sell that to you, but I'm not sure that I could actually fulfill on it. Because companies were really dependent on this for their important systems. So I said, well, if you pay me, and I started hiring people and turned it into a company, which is now known as Particular Software. And, tens of thousands of developers all over the world just sort of, at this point in time, they come to a company and everything's already there, and they take it for granted that Whether we're using RabbitMQ or Azure Service Bus or Amazon SQS or whatever, there's just this layer and it solves those problems for us, and we can focus on our business logic. But it still kind of surprises me when I meet developers that have never done any real asynchronous programming sort of in a distributed sense. And they're still just kind of doing the request response RPC model. That's sort of the nature of the industry that we're in. It just grows so rapidly, right, and so many new people come in that kind of each generation needs to relearn the mistakes of the previous ones. So whether it's shows like yours or .NET Rocks or my blog or Twitter or whatever, we're kind of all out there trying to spread the lessons learned from the previous generation. But as you've said, after a while you start to feel like you're repeating yourself because you've been doing this so long. And then it's like, no, some people haven't heard this yet. And even though this is the 27,000th time that you've said it, it needs to be said one more time.
Yeah, I don't think you're going to run out of audience because there are so many more programmers coming into the industry, and there's so many more companies building custom systems and wrestling with this problem.
Yeah.
So companies are building new software systems. Companies that don't even think of themselves as technology companies have hired developers, and their development teams are building these systems. And a number of years back, there was this sea change, and people started giving large integrated systems this negative word, the monolith. And now this conversation has started about, okay, how do we break these things up? And there's these new buzzwords, microservices, and then there's some kind of timeless principles. Can you help us bring all that together so we can kind of ground the conversation here and try to figure out what microservices are and what may be a nugget of new and what may be a lot of existing art?
Right. Well, I think that you really called out a trend that's been kind of been going on for some time. More and more companies or organizations, it's true for governments and nonprofits and just everywhere, that realize that software is not optional anymore. The scale of problems that we're trying to tackle as a society keep growing in terms of scale and complexity. So, if you're a programmer, then congratulations, you pretty much have job security for the rest of your life. The challenge then becomes, how do we handle these bigger, more complex pieces of software? We've been, as an industry, trying to tackle this problem for a long time. I'd say that the first word to call out is that word monolith, because its meaning has changed in sort of the common lingo in the industry. So monolith, if you just kind of look at it sort of from a dictionary perspective, is this indivisible slab that has no natural internal structure to it. It's monolithic, means you can't really break it apart. Now, historically, what that meant was it was a logical property of the software, more so than a deployment element to it. But if you can't logically subdivide the software, then you can't really physically deploy it in different pieces that well either. But the original concept of the code being monolithic was about just how much logical coupling there were between the different parts of it. So what nowadays people throw around the term modular monolith, it's something of an oxymoron. It's saying, well, if it's modular, then logically speaking, you have successfully broken it apart. it's no longer monolithic. But as microservices became a thing, monolith started to refer specifically just to the deployment style of saying, I'm going to deploy everything into one big process rather than into a number of smaller processes. But historically, if you had modular code that you deployed to a single process, nobody would have called that a modular monolith. They'd say, you've got modular code and you're using fairly simple, straightforward deployment strategies for it. And that's fine and normal and natural. You don't create more moving physical parts without a good reason to do that. So that's kind of one of the shifts that happened, sort of the Microsoft craze brought about. But I think that one of the pieces that's missing is still that element of the modularity. It's the finding correct module boundaries isn't easy. Well, it never really was easy. And it looks like, again, partially because of or related to just sort of the huge influx of more programmers and more companies building more software than before, that things that we've tried as an industry before and realized they weren't really effective are being retried again this time around. So having a base layer of entities and a layer above that of some kind of functions that manage those entities, and higher orchestration level code, which is managing the underlying functions and the underlying entities, that was documented as a style of architecture. So there's a very good book. It's a little bit old, called Patterns of Enterprise Application Architecture, that describes a number of styles of dealing with large complex code bases. It says, well, if you have this type of layered style of interaction, but that most of the logic is outside the entities rather than inside the entities, essentially you're building a transaction script. And that's not necessarily a bad thing. That's suitable for certain simple types of logic. But for other types of logic, you want a different style. That's a domain model pattern. Now, in the domain model pattern, the element of saying you're going to have entities is to be expected, but that a lot of times the complexity of logic around those objects and the needs for transactional consistency kind of meant that you needed to keep them all together. Now, what's been happening in microservice territory is that people are saying, oh, entities, we're going to have a microservice for each entity. And then we're going to have some other microservices, which then call and manage those other microservices. And while that's probably fine for, let's call it the transaction script style, where it's appropriate for simpler types of business logic, when you have more complex kinds of business logic and you want to guarantee consistency around this set of data, then you really want transactions. But at that point in time, people are like, well, I'm not going to do distributed transactions between my microservices. That's bad. And then they start looking for other ways to enforce consistency between those microservices, rather than kind of going back and saying, no, you're using the wrong module boundaries. What you need is something different that encapsulates the logic and the data better and can provide a consistency boundary around that. In domain-driven design, the book, they describe a pattern, they call it the aggregate root pattern, where the primary attribute of an aggregate root is that it is a consistency boundary. But again, the thing about an aggregate root is that it fully encapsulates any other entities that fall underneath that space.
Mm-hmm.
But once again, that kind of, people assume that, because I'm calling something an aggregate root, then I can deploy that as a separate microservice from the other things that are supposed to be a part of that aggregate root. Then they don't even realize that they've lost this consistency boundary. So I think there's, understanding that there are a lot of patterns around these things, and that it requires real domain-specific work to find what are the right places to break things apart, and that the industry has spent the better part of 20 years at least documenting different approaches to that and saying not one of them is best. They have different kinds of applicability. And in the past, if you got the boundaries wrong, then having everything deployed together and flowing transactions around it wasn't a great solution. But so long as everything was in one database and you just had sort of one big process managing it, then it wasn't awful. Now with microservices, where people are saying, I want different microservices, and each microservice can have its own database and have polyglot programming and polyglot persistence, and they're introducing a lot of network boundaries in the middle. If you get things wrong, you're incurring a lot of hops. And if you don't have the ability to do distributed transactions and you end up sort of re-implementing that yourself, you're going to end up with a very slow and people throw around the term eventual consistency a lot. But I don't hear enough people saying, well, the real risk is eventual inconsistency. It's if you did this wrong and the system ends up eventually in an inconsistent state, how would you know?
Yeah. And
if somebody found out, said, oh, crap, our data got into an inconsistent state, how do you get out of that? I don't think it's something that people really give enough thought to. It's so it turned out 3 weeks ago, our system went from being eventually consistent to eventually inconsistent. So what do? We just throw away the last 3 weeks of business? We can't do that.
Right.
But, we're going to be audited by the IRS. We have to have our books in order. We can't have, the numbers not add up when it comes to money. So, these are really big, scary problems that I don't think that enough developers appreciate with regards to setting boundaries and managing transactions. And 20 years ago, there was more of an appreciation. You didn't just turn off transactions without having some really serious conversations. But I think essentially that's what we've done with microservices, is we sort of turned off sort of overall process level transactions because they are spanning multiple microservices.
The Azure DevOps Podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
So one of the basic questions I think that a lot of people have is, how big is a microservice? And micro seems to imply small. And so if they were going to, let's say they had a system with 100, they made 100 database tables and corresponding screens and entity classes and objects and all that. And they're thinking, okay, do I split this up in 2 pieces, or do I split it up into 100 pieces? How would you recommend they go about making those decisions?
I think that the first mistake that we make consistently is limiting our view to just a single system. Because there is so much, and you mentioned this in your opening remarks, there's so much system-to-system interaction and integration going on that we kind of say, oh no, that's out of scope. It's like, well, really? Should it be? Is that not part of making the business function correctly? Do we not need consistency between different systems? So I think we move too quickly to limit our view to say, this is just the system that we're looking at. And part of that has to do with how a lot of IT is managed, in the sense of, we create a project, which is a unit of budgeting and a unit of staffing for a specific system, where sort of the assumption is that context is correct and makes sense. But that's more of a sort of historical accident, in the sense that, in the past, when there wasn't a whole lot of system-to-system integration going on, then that might have been a rational way of planning and designing things. But in the connected world that we're currently in, it's hard to continue and pretend like that integration doesn't matter. So we say, this microservice owns certain piece of data. It's like, well, what about the other systems that use that data? It's like, oh no, they're out of scope. It's like, well, do they have their own database with that own data in there out of scope? They're like, well, yeah, they might. So how do you manage the consistency between those things? Oh, that's not our problem. That's a different system. That's a different team. We don't need to worry about that.
Yeah, troubleshooting it.
So I think right there, it's, before a single line of code has been written, before a single repository has been set up, just sort of the boundaries at which we look at are overly narrow and constrained. And even if we theoretically could get everything perfect within the boundary of one system, I don't think that's enough. I mean, and then trying to have each group in the organization come to some sort of local optimum without really syncing up with other groups kind of doing the same thing, it's just setting ourselves up for failure. So if we want to be serious about this, and that's ultimately, while people could say that the microservice thing is sort of a wave that was sort of a reaction to the big enterprise-wide SOA thing that came before it, we need to stop and ask the question, say, well, why did we 10 years ago come to the conclusion that we needed to look at things enterprise-wide when thinking about services in the first place? And say, oh, that was heavyweight. Oh, those guys were idiots. It's like, there is something to be learned from history. Let's not throw out the baby with the bathwater. And we don't have to take all of history as is without questioning any of it. But we also shouldn't have to rediscover certain things that were already figured out before. So that element of saying, understand that integration matters and that the enterprise-wide usage of data, if you want to talk about having microservices and ownership and independent ability to deploy into version, then you don't want to be breaking other systems across the organization when you're doing that. So I think that's, to your question, well, where do we get started wrong? It's the right there of just looking at a singular system. And obviously that's, those decisions are often, let's call it, above my pay grade for many
Sure.
developers that are out there. But it's our responsibility to help percolate that message upward and say, we need to start looking beyond just a system by system perspective.
Sure. So there's a lot of teams that either have an existing legacy system that they're figuring out how to modernize, or they want to break it up, or they're building something new. They're in the midst of building something new, and they're thinking, okay, do I have one Visual Studio solution or multiple Git repositories? And they're really trying to make concrete decisions. So what can we give them for how to move forward if they really don't want to end up with maybe the inflexible monolithic system that perhaps they have in other parts of the company?
Right. I think the first thing to realize is that modernization and or design decisions are never really going to be a one and done type of thing. It's more of this sort of gradual bootstrapping process of saying, well, we need to deliver something of value to the business. We can't just spend all of our time in our architectural ivy tower and say, well, what's the right way of doing this? And there are a whole bunch of constraints. As you mentioned, we might have a legacy code base that we can't just change all of it all at once. So those elements of, should I have a single Visual Studio solution or multiple? Should I have one single repository or multiple repositories? Is going to be very much influenced of, well, what's your current state? And, what is feasible in terms of sort of the next round of improvement that you can do to your structure and to your software delivery pipeline. Knowing full well that after you take that round of improvement and deliver more business functionality, you may come back to that another year and a half later and say, well, that was good for where we were at the time. Single Visual Studio solution was good. Now we're going to do multiple Visual Studio solutions, but still in the same repo. And then we're going to run that for some period of time until we're going to say, we want to break that apart further and have even stronger boundaries. And we're going to move to multiple repositories. So I don't think that we can kind of say, well, what should somebody do? Because it's very tactical. But I think that what we can do is we can say any organization should expect to continue to iterate and to improve on those things, and that what makes sense at, let's call it level 4, doesn't make sense at level 2. So telling people, well, you should be multi-repo, say, well, if you're ready for that step, then that makes sense for you. But if you haven't yet done A, B, or C, start there. Lay the groundwork first. And part of that story of the modular monolith sort of comes back to that and say, look, if you're not yet confident enough in the modularity of your solution, then deploying it into different microservices is actually probably going to be more painful for you than deploying everything in a single process. So I like that as an industry, the term was introduced as a pushback from microservices means that everything always gets deployed, and that we're in this. No, you can start here and build in some modularity at that level, and then gradually build up from there. And when you have really good module boundaries, where you have strong data ownership, such that data doesn't need to be shared, whether that is sort of in a publish-subscribe manner, or whether that's in just passing a whole bunch of data request response, then multi-repo starts to make sense. as well as separate deployment units, because then you'll start to get benefits from them.
What I hear you saying is if someone says, okay, I need to be using microservices because that's really the modern architecture, what I think I hear you saying is, don't worry about it. Just think about the appropriate level of modularity for you.
Right. Well, I think part of it is sort of getting an appreciation for the longevity of software. It's saying, look, if we do our jobs right, the organization is going to continue maintaining and enhancing this code, ideally for another 10, 20, 30 years. So, it's a long game. It's not you need to get it right now. Otherwise, the ship sailed and then you're stuck, or the organization is stuck. I mean, coming back to NServiceBus, I can tell you all of the original code that I wrote in NServiceBus is gone. Not only is it gone, it's gone several times over. It's been rewritten and then rewritten again a number of times since the NServiceBus 2.5, which was when it was made commercial. And occasionally I still hear people saying, "Oh yeah, we're still using 1.9 in production and it works fine." And then I'm kind of horrified in the sense of, please, no, get off of that. It is so much better now. Like, no, if it ain't broke, don't fix it. But I think
means that you did a great job back then.
Well, it was a good job, or as best a job I could do under the constraints at that time as sort of a single person, working nights and weekends and whatnot. And I think that also, organizations, specifically those that are closer to management type positions, need to come with that sort of perspective of saying, no, it is to be expected that we will gradually and periodically rewrite these different things, and that it's not ever really supposed to be done. In essence, we're building, to use the term software product rather than a software project, where, again, if we do this right, we're going to continue releasing new versions of this product for the next 10, 20, 30 years. So we need to take more of a long-term mindset towards preserving that knowledge and continuous learning and continuous improvement, rather than trying to get everything perfect out of the gate, and create greater, what's the word I'm looking for? A greater appreciation for the gradual maintenance and refactoring and improvement, where what I see happening is usually the most skilled people in organizations are directed to go and write the brand new system. You build it right from the get-go, and you leave the maintenance work to the less experienced people. But then you just sort of create a problem where, even theoretically, if the software could have been built perfectly to begin with, and that's a stretch, then other people who don't know how to continue to maintain it over time, and they're not getting sufficient on-the-job training or mentoring by the more senior people in the organization, then the software is not going to survive and thrive in the long term. It's going to wither and die, and then we're going to have to rewrite things again. So that's unfortunately the cycle that we're in as an industry, but it's just as much a people and process and planning and management problem as it is an architecture and design type of problem.
And with so many new people coming into the industry, that's likely going to be a problem for some time.
Right.
But hey, it's a challenge. We work through it.
Right. So, if we zoom in and say, well, yeah, as you said, for the developer saying, all right, all of that is fine and good, but I have a thing in front of me right now. How do I design that? What I can say, again, historically is that the more loosely coupled you can make the interaction between two things, the better. Now, on the spectrum of loose coupling, having things that share objects in memory is the most tightly coupled. Having less and less shared state and more explicit interactions between those modules, generally speaking, is better. The less data that you can pass on that communication, also the better. So if you're passing 50 fields in a request response, that is going to be more tightly coupled than if you're passing 5 fields, right? And no, hiding 10 fields underneath each one of those 5 fields in an array or a struct or something doesn't count.
Right.
You actually have to reduce the sort of the real amount of business data that's being passed around. Similarly, if the nature of the interaction is more asynchronous in the sense of, I raise an event or I fire and forget a command, and I can continue doing meaningful work without waiting for a response, that's a higher degree of loose coupling than if I am blocked until I get a response. Now, the important thing to realize as you're moving through the spectrum towards more loose coupling is that oftentimes the way that you do that is by taking bits and pieces of responsibility and moving them to the other side of the boundary. So in my experience, and I've been doing this a long time, you can't really know what the right boundary is up front. It's more a process of iterative discovery, of kind of going through field by field and function by function and kind of shifting stuff between one pile of responsibility and another, and coming out with something. Here's a litmus test that I found indicative of a good solution. So usually a good solution does not have an entire entity on one side of the boundary or the other. Usually you'll see different fields of what would have been called the same entity kind of subdivided on either side. So to give some really brief examples, in the retail domain, we'd often model a product entity where a product has an ID and a name and an image and a price and an inventory level and all those types of fields. In a good subdivision that has strong modularity and greater decoupling, what you'd expect to see is name and image type information in a different module than the price or the inventory, because those things are largely independent of each other and don't need to take part in the same transaction. So if we're changing the price of a product, usually we're not changing its name or image at the same time,
Right.
And vice versa. So historically, if all you had was a product entity that had all of those fields, you could update everything all at once. But if you kind of look at the way that data moves and changes in the organization, you see that not all fields change all at the same time. So putting those fields in different places, all indexed by the same product ID, is a reasonable form of introducing modularity and decoupling.
That's a good point.
So that's kind of an indication that if you don't have a product, or let's call it a full entity, in any service, then chances are you're heading in the right direction. And conversely, if your microservices are very entity-centric and they have everything about a given entity, then as a litmus test, if you're dealing with complex logic, that's probably wrong.
Mm-hmm. So you have, as we wrap up here, you have quite a bit of resources that our audience could take advantage of. You got week-long on-site training classes. You got free online training videos and other things. Which ones would be most relevant for our listeners to look up?
Well, there's a ton of stuff available, whether it's YouTube or Vimeo or those types of things, presentations that I've given at various conferences. Definitely look those things up. We'll include in the show notes a couple of specific ones on this topic of microservices and boundaries and those types of things. And yeah, I also offer a week-long class for people who are really committed to going deep on this and want to figure out how to do that. And we'll also include a link to that in the notes that people can find. And I think the most important thing to realize is that each generation of programmers took years to figure out how to do this stuff right. It's not easy, and it takes a fair bit of effort and trial and error to kind of figure out how to do this better. So for each of us to be patient with each other and to spend the time learning those things and communicate that to whoever is setting the deadlines and say, look, we're probably going to need to rework this a couple of times while we're figuring out this stuff.
That's a good point. You and I and Rocky Lodka had a great conversation at the MVP Summit, and it was not a debate because it was conceptually we were pitching out architectural concepts, and we were each trying to imagine a world where we were using the concept espoused by the other and then evaluating what that world would be like. And that was very productive, and I really enjoyed that conversation.
As did I.
All right. Well, thank you very much, Udi. Besides searching Vimeo, YouTube, and those resources that we'll include in the show notes, is there anything else that listeners should go and look up right away?
Well, I think that if there are people that are already doing a kind of asynchronous interaction between their microservices using some kind of queuing system, then I'd say take a look at NServiceBus. Me and my team haven't spent 10 years plus working on it because this infrastructure is trivial. There's a lot of really difficult things to get right. And if you get them wrong, it's not like your software is going to blow up tomorrow, but you can end up in that sort of eventually inconsistent state. And that's a real pain to figure out. So, if you're looking for infrastructure to support this kind of thing, take a look at NServiceBus, try it out. If you have questions, there are discussion groups, there's chat online, whatever. We'd love to explain why we think this infrastructure is an absolute necessity for anybody building these types of asynchronous queue-based distributed systems. But as I said before, at least part of our work with customers is saying, look, your boundaries are wrong. Let's get your boundaries right first. And then NServiceBus will sort out the rest for you.
Right. And man, I can vouch for NServiceBus. Been using it, leading teams, building software with it since the open source versions 10 years ago. And to this day have current active systems with it. So it is a really good product, and there's not many options. There's not many options at that level out there.
No, I mean there's mass transit, which is a very good open source alternative to NServiceBus. It unsurprisingly lacks 24/7 support and production monitoring and debug tooling and all those types of things. But for people that want to get started with something, much better use mass transit than go and build something yourself. So I'd say that's kind of the first step is realize that there's a lot of tricky stuff to get right. just at the level of that kind of framework. Over time, you'll realize that managing a distributed system at scale requires additional pieces that, as you mentioned, Jeffrey, really are only available in something like NServiceBus. And while I think that you can start for free with NServiceBus, and that it is probably code for code a better alternative, I do know that there's a lot of people out there using mass transit, happy with it, and we would be remiss to not call it out as an option.
Right. Well, awesome. Hey, this was a great conversation. Thanks so much, Udi, for visiting with me.
Well, thanks for having me, Jeff. Really appreciate it.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.